Building a Serverless Web Calculator on AWS, a comprehensive step-by-step guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction, Project Overview and Prerequisites. Building and deploying serverless applications is becoming increasingly popular in today's cloud-first world. This podcast will walk you through creating and deploying a fully functional serverless web calculator on AWS. Using services like AWS Amplify, AWS Lambda, Amazon API Gateway, and AWS DynamoDB. By the end of this podcast, you'll have a working calculator that performs basic math operations, stores results, and can be easily extended with additional features. Prerequisites. AWS account. Basic knowledge of AWS services, Amplify, Lambda, API Gateway, DynamoDB. Familiarity with Python and JavaScript. AWS CLI installed and configured. Basic understanding of HTML/CSS/JavaScript. Creating the front end, designing and deploying the calculator interface with AWS Amplify. The first step in our project is to design and deploy the calculator interface using AWS Amplify. Amplify simplifies web application deployment by automating the setup of hosting environments, C/CD pipelines, and more steps. Initialize Amplify project. Use the AWS Amplify CLI to initialize a new project in your local development environment. Amplify init. Follow the prompts to configure your project, selecting the appropriate settings for your application. Build the calculator interface. Create a simple HTML/CSS/JavaScript interface for the calculator. The interface should include buttons for numbers and basic operations, addition, subtraction, multiplication, division, and a display area to show results. Div id equals calculator greater than. Input type equals text ID equals result read only. Div id equals buttons greater than. Less than, number and operator buttons go here, greater than. /div. /div. Script src equals app.js/script. Deploy the front end. Deploy the calculator interface using Amplify's hosting feature. Amplify hosting add. Amplify publish. Your calculator frontend is now live and hosted on AWS. Implementing calculation logic, building a serverless Python Lambda function for math operations. With the front end ready, the next step is creating a backend service that handles the calculations. We'll use AWS Lambda to create a serverless function that performs these operations. Steps. Create Lambda function. In the AWS Management Console, navigate to the Lambda service and create a new function. Choose Python as the runtime. Write the Python code to handle basic math operations. Import JSON. Def lambda _handler event, context. Operation equals event operation. Num1 equals float event num1, num2 equals float event num2. If operation equals add. Result equals num1 plus num2. Elif operation equals subtract. Result equals num1, num2. Elif operation equals multiply. Result equals num1, num2. Elif operation equals divide. Result equals num1, num2. Else. Return, status code, 400, body, json.dumps invalid operation. Return, status code, 200, body, json.dumps result. Deploy the Lambda function. Deploy the function and note its ARN, which will be needed for API Gateway integration. API Gateway integration, setting up a REST API to connect the front end and back end. We'll set up an Amazon API Gateway API to connect the front-end calculator with the Lambda function. This will allow the front end to send requests to the back end for calculations. Steps. Create a new API. In the API Gateway console, create a new REST API. Define methods, for example, post, for the API, linking them to the corresponding Lambda function created earlier. Deploy the API. Deploy the API to a stage, for example, prod, and obtain the invoke URL. The front-end will use this URL to make requests. Integrate front-end with API. Update the front-end JavaScript code to make API calls using the Fetch API or Axios to the API Gateway endpoint. Function calculate operation, num1, num2. Const URL equals your underscore API underscore gateway underscore invoke underscore URL semicolon. Fetch URL. Method, post. Headers. Content type, application/JSON. Body, JSON.stringify operation, num1, num2. Then response equals greater than response.json. Then data equals greater than. Document.get element by id result. Value equals data. Semicolon. Data persistence, storing calculation results with AWS DynamoDB. We will store the calculation results in a DynamoDB table to add a persistence layer. This allows us to retrieve and display past calculations if needed. Create DynamoDB table. In the DynamoDB console, create a new table to store calculation results. Define the necessary attributes, for example, operation, num1, num2, result. Update Lambda function. Modify the Lambda function to save the calculation result to DynamoDB. Import Boto3. DynamoDB equals Boto3.resource DynamoDB table equals DynamoDB.table calculator results. Def Lambda underscore handler event, context. Hash existing logic. Table.put underscore item equals. Operation, operation. Num1, str num1. Num2, str num2. Result, str result. Return, status code, 200, body, json.dumps result. Conclusion, project recap and future development possibilities. In this podcast, we've built and deployed a serverless web calculator on AWS, utilizing services like AWS Amplify, Lambda, API Gateway, and DynamoDB. This calculator performs basic math operations and persists the results in DynamoDB. Future development possibilities. Enhance the calculator with additional operations, for example, square roots, exponents. Implement user authentication to track individual calculation histories. Build a more sophisticated front-end with a framework like React or Angular. Add error handling and validation for more robust user interaction. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.